Microphone check. Microphone check. 1, 2. I think y'all can hear me now. Y'all let me know. Went downstairs for just a couple seconds and it's already time to stream. I know I left y'all in suspense yesterday. You were tuned into the network. The YouTube channel that takes complex networking topics, dumbs it down to a more simple language. And y'all know how we do on this channel. We try to lab every day. Don't have my lab every day shirt on. I don't know where that mug at, but anyway, that is the concept that we try to live by. The mantra. We got Guy, you in the building. We got Matt, Carol in the building. Appreciate you guys for tuning in and keeping that chat jumping over there. Let me what the hell was I gonna do today? That's right. We was gonna do the lab from yesterday. Y'all remember the lab I got stuck on, right? The campus lab that we was working on for past couple weeks, actually, right? We started out doing some static routing on it, and we built upon it and did some EIGRP, some BGP on there. We did some redistribution of those routes, and we went back and to the central wide area network over here. So in case you guys are just tuning in or just seeing this lab right here, we worked on this central. We started out with this central wide area network with these two cities, Orlando and Tampa, right? Shout out to UCF. That's where I went to school. And then we worked on some static routes in the wide area network over here. Then we added another city. We added Daytona right over here, and then we had these routers right here participate in the GRP and created pretty much a ring between those guys and a default route out of the local area network for Daytona. And then since we had EIGRP running over here and then we had BGP running over here, we had to create two-way redistribution, right? What's that? That's like when you have, like in this case, we have a EIGRP over here and we have BGP over here. For these two routes to kind of like, how do I say, advertise their routes to each other, we had to do what's called two-way redistribution. So the EIGRP routes redistribute into here, and then the BGP route redistributed into here, so that way they know about each other's routes, right? And this guy right here would be considered what? The ASBR, Autonomous System Boundary Router. He sits between two autonomous systems, BGP over there on the left and an EIGRP on the right, and he just act like a middleman. This guy over here talks BGP. These guys talk EIGRP, and he just kind of sits between among the two and kind of translate the routes between the two, right? And that's what he did over here. And then this guy kind of did the same thing too, but he's got these static routes over here, and he got a BGP route over here, and he kind of did the same thing. Now, where we got stuck at was when we shut this route down, because remember my boss created this lab, and he just kept adding more shit to it, and it just made it harder and harder. And then for the final task we had to do, let me see if I got those tasks still. I don't think they're in here. Let's see. Let me see if I can pull that up. It was one that said that full tasks or something. Let me see if I can pull that up. Let's do an open real quick. Let me see. They in here. Yeah, I'll give you a second. The full tasks. There it is, right there. And these were the final tasks. Remember, we did all this shit from the past couple videos. So if y'all want to catch up, you're going to have to start off maybe about 5 or 6 streams back. I don't know, maybe 7 or 6 streams back. That was the first couple tasks. Then we did the floating static routes. Then we did mutual route redistribution, which we just talked about. EIGRP spanning tree. Then we did the HSRP and static routing. That's what I forgot to tell y'all. Then we did some more redistribution. And then we left off right here. We did... we ripped out all the static routes here, well, most of them, and then we added BGP among this ring right here. And then where we got stuck at was this final task, like I said, right here, where he said, from router 1, configure serial 011, which was, this is router 1. He said, configure that interface right there to be a backup link for all host networks in case failure occurs on BGP between router 1 and router 4, which is this link right over here, and router 1 and router 2, which is this link right over here. So we ended up doing was we was able to ping from Orlando to Tampa and Daytona, right? But then when this link shut down and that link shut down, that means the only way we can get to those other routes, those other cities, was through this link right here. But then in the last stream, remember, I spent a good maybe an hour trying to figure this shit out, right? It would just die right over here. Well, just a couple minutes before this stream, or before I said I'm gonna go live again tonight. I said, let me try to figure this shit out, and then I think I figured it out. I fixed it. I don't know if this is the way he wanted it done, but basically I just created a couple more static routes to go back, and that's how I was able to fix it. Now I don't know if that's how he wanted it done, because I thought BGP would have let us still be able to get to those networks when those two other links, when this link shuts down and that link shut down. But the problem is, I think it created a routing loop, and I'm gonna show y'all how that happened, right? So we're gonna give it a couple of minutes for some people to tune in, and then y'all hit me that like button, y'all hit me that subscribe button, and then we'll get right onto the show. I'm gonna show y'all how I figured out the solution, and then we'll work on a Boson NetSim lab. What I wanted to read about was what was it? The two vulnerabilities. I think we kind of talked about the F5 vulnerabilities. I don't know if you guys are familiar with F5. They create, it's a vendor that has a line of firewall products, and they also have load balancers amongst other things. Well, they basically found a vulnerability in their software, and this company is like scrambling to patch the shit up, right? And normally, what is the company? I don't remember who it is, but I think it's an organization called CVE. They have these, what they're called CVEs, or common vulnerabilities and exploits. Well, they give you when something is like a real huge exploit or vulnerability in whatever they find, like a patch or something like that, or like a hole in your network or a hole in your software. They give you a scale of 0 to 10, right? And 10 being like you better like scrap this software or really like patch it up because it's an emergency. It's a real flaw in the software. Well, this vulnerability, there's two vulnerabilities in F5 software, and they got a 9.8 severity rating. Two vulnerabilities with 9.8 severity ratings are under exploit. A third looms. So yeah, they just really, I hope the guys that develop the software are also polishing up their resumes. Security flaws in VMware and F5's big IP are being exploited by malicious hackers. Malicious hackers, some believed to be state-backed, are actively exploiting two unrelated vulnerabilities, both with severity ratings of 9.8 out of a possible 10, like I just told y'all, in hopes of infecting sensitive enterprise networks with backdoors, botnet software, and other forms of malware. The ongoing attacks target unpatched versions of multiple product lines from VMware and of big IP software from F5. Security researchers said both vulnerabilities give attackers the ability to remotely execute malicious code or commands, and I did a couple patching, some patching for these, load balancers. Give the attackers the ability to remotely execute malicious code or commands that run unfettered root system privileges. Never heard that word, unfettered. That's word of the day right there. The largely uncoordinated exploits appear to be malicious, as opposed to benign scans that attempt to identify vulnerable servers and quantify their number. On April 6th, VMware disclosed and passed a remote code execution vulnerability, tracked the CVE number, blah, 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 and I'll give you all the code for any you CVE nerds out there, and a privilege escalation flaw, tracked the CVE number, blah, 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 blah. According to an advisory published by Wednesday by the Security and Infrastructure Security Agency, malicious cyber actors were able to reverse engineer the updates to develop an exploit within 48 hours and quickly began exploiting the disclosed vulnerabilities and unpatched devices. So basically they said, okay, we found the vulnerability. We're going to go ahead and patch it. And the hackers were able to break that patch within 48 hours, and yeah, this is crazy, man. But I'll give y'all a link to that software and the CVE number for any of you CVE nerds out there. We got my man Mark Anthony Peacock Jr. in the building. Appreciate you for tuning in, man. We're gonna get with the lab in just a second here, but that's the CVE number for any of you CVE nerds out there. We have I feel sorry for those software developers that work for that company. They gotta patch shit up like it's a goddamn like the we got Anders Tech in the building. Appreciate you for tuning in as well, man. You a day one, man. Ever since I've been streaming, you've always been on on the streams here. But anyways, let's head on with the show. I think that's pretty much everybody that's gonna be tuning in. But anyway, so where we left off at, we left off last night, right? We said that final task. Let's just do a recap for anybody that didn't watch last night. He said to remove all the static routes from all the routers, right? He did say that, but he also threw this caveat in there: some may still need to be used, and that should have clued me in right there.
You stupid.
Configure BGP between these routers, which is basically the central wide area network. This central ring right, this ring right here. We had to create BGP neighbors amongst these guys right here, which we did too. Had no problem doing that. It was wash, rinse, repeat. On both core and Tampa core, those two core switches, we had to replace the static route with a default route, right? So we had a static route going from all of these other networks that said, hey, if you want to get in this network, take this hop. If you want to get in this network, either way, that was the next hop. So we removed that and we said, create a default route. Remember what I said the default route is basically a route that take you out of your neighborhood, right? So if you have a city that you're trying to get to, I don't know, I always use LA as an example. You want to get to LA. You don't know how to get to LA. You know there's a million roads to get there, right? But you know how to get out of your neighborhood. That road that takes you out of your neighborhood, that one road that takes the main road, that main artery that gets you out of your neighborhood will be considered a default route. Well, if you look at, say, Orlando, we only got one way to get everywhere anyway, right? So this was our default route. We got rid of the static routes that we had built on here and just said, okay, this is the default route. If you know we need to go anywhere, just take this way anyway. There's only one way out of there anyway. Same thing with Tampa. We said to get to any other network, take this way, right? And that's what we did there. And then what else we did? Inspect all routes. Then we kind of looked at all the routing tables. We saw how BGP was being advertised throughout the networks. And this is what I really should have really done. And I think I would have seen this. Make sure you understand the traffic flow and why. He should have put that in all caps. If he had done that, I would have been like, oh shit, there's a routing loop. And I think that's what happened there. I think there was a routing loop. So once we did all of that, we was still able to ping from Orlando to Tampa. Let's go ahead and do that. Anyways, just to verify, right? Just in case the shit broke while I'm sitting here trying to explain this shit to y'all, right? Let me see. Hold on a second. Y'all make sure y'all that join that Discord server, and you'll get a heads up on these labs and what we're going to be working on, and whether I figured something out. Put a link in the chat for the Discord server in case you want to join, and you make sure you like and subscribe. And let me put that in here right over here. And we're gonna ping in just a second. Hold on. Here. Bling. That's the link. And then what else I wanted to do. Okay, so I'm gonna have a PC in Orlando ping any PC in Tampa. Let's go with this guy right here, PC4. He is 10.10.11.10. I know it says .0, but that's the network. So he's .10, right? 10.10.11.10. So we're going to ping 10.10.11.10. Wait for it. Get on our knees, pray to the network gods. Sometimes it take a while for these pings to go across. I think it just has to do with sometimes, I don't know if that's a packet tracer feature or if they're really trying to simulate how the networks work, but
1 week later,
we got 75%. So one of the pings came across, and there it is right there, right? We'll try it again. And finally it came across, right? That's a good sign. So we were able to ping from Orlando to Tampa. Now let's try to ping Orlando to Daytona, which is the PC back here, 10.32.10, right? 10.32.10. Pin 10.30.2.10. And he looked like he gonna take a while too.
2 hours later.
It timed out. Wait for it. Come on, man. Now we could click the simulation button right here and kind of like fast forward through life. And then make it work, but shit, man. I'll try it again, right? And there you go, right there. See there, now it came across. So I used to get nervous and be like, why the fuck this? Oh, okay, now it's working. And I think I cut off a stream, maybe a couple. Now that I think about it, a couple streams back. I'm like, man, it ain't working, man. I'm sorry, y'all. We gonna have to. And then as soon as I stopped record, I pinged it again, and it worked. So I gotta be patient here and wait for all these routes to propagate, et cetera, et cetera, et cetera. So that, and I think it helps with ARP caching and stuff like that. So anyways, we're able to ping Orlando to Tampa, Orlando to Daytona. And this final task where we got stuck at was to configure this serial route and create that backup link, right? So which was, basically it took those other routes to go around here and that way, etc., right? So now we're going to shut this link down, shut that link down, and make sure that the traffic go this way, right? And see if we can still make it there. And I think that's where the problem lies, right? This upper link, I believe, is gig 000 or 001, rather. Let's see. It's 001, and then that link is serial 010, right? So we're going to shut those down and check that out. Hang on for just a second, y'all. Make sure I move these windows over here and close that. Yeah, that's crazy with F5. Every time they keep talking about it, I thought that shit was over with, man. But it looks like F5 they stock probably, well, the stock market is in general is down to shit. But so now, is that on router 1? Yeah. So we're gonna turn off that interface, right? Gig, where's he at? We'll do a show IP interface brief. Just double check. We're going to shut off this interface and that interface, right? And that's supposed to be the backup link. So I believe it's gig 0/0/1. Shut that bad boy down, right? And we got some BGP notifications. They'll be like, hey, look, we got all these routes going down, and let the other routers know. We got this route going down. That's why it's red, right? Now we're going to turn this one off, right? Which was, I believe, 0/0. So interface 0/0/1/0 rather.
You stupid.
Shut that down. Right, so now let's see. I believe it's 010. Yeah, now it's red. So now this link is down, right? So now I believe he was taking those other ways to like Tampa. He was going this way to go there. And I believe coming back he was going the other way, something like that. Right? And remember, we did that maybe the very first stream when we started this lab. We my boss he made us go to Tampa like this, right? We first made the Tampa go like this. But the tricky part was he made us go take the opposite way back, right? That was where the problem was, right? But now that this link is down, y'all see where I'm getting at right here, right? First he took this way to get there, right? That was the original route to make it to Tampa. Or one of these right here, right? But coming back, he made us take the opposite way to come back. I know some of y'all might call it asymmetric routing, right? But this was just to practice static routing. Coming back, it would stop right here, right? Now, like if you look at it, you'll see it'll stop right here because this link is down, right? We had to go to chew up that fiber cable, so it's not gonna go this way, right? This here and where the problem lies. So now that we've done that, let's see what happens, right? And we'll even slow it down with the simulation mode right here, so we can see what happens, right? So let's try to ping. Let's see. Let's pick one of these PCs. We'll pick this guy, which was quad 10, right? So we'll ping 10.10. Oops. 10.10.10.10. And we already saw, actually, let's not even do it. Let's do a ping. We already know, we already know it's going to die, right? Let's do a trace route. Y'all know what that is, right? We'll see where it dies at, right? Okay. First hop was 10.20.10.1, which is what? Boop, the default gateway right there. Next hop was 21.2, which was, boop, the next hop. After that, it dies. It don't know what to do. It does not know what to do, right? But I remember last time it died right over here. So that's what's weird to me. Let's try the other PC. This one right here. 10.10.11.0. Let's try that. We already know it's going to die, so let's kill that, right? Let's ping the other one. 10.10.11.0, which was 11.10. Ping him, and he kind of dies there too. 10.21.2. I hope I didn't say he died right over here too. He didn't know what to do to that packet, basically. I remembered it dying here last time, so I don't know. We need to figure something out over here. But let's see. Let's see what he did to make it there. Let's do this. I'm gonna bring this back up, and see. Yeah, I'll make sure. Okay, that's what it was. So we had to create that floating static route to go this way. That's what it was. Let's make sure that that's in there, right? Show IP routes. Let's just look at the whole routing table route. And then the 80, 10, 10, with the 90, what is it? This one, 80.10.10.0 need to be in there. And it is directly connected, but it should have been a default route. So let's do a show run section route and then take a look. And I believe to make it a 10.10.11.0, I believe it was this one right over here. He said to make it 10.10.11.0, take this. But we really wanted to take the 80.10 network, which was, he has it in BGP. Not right now. Let's see. No, that's not it right there. It should have been a floating static route that would have been brought back up. And I thought I put it in here in the last stream. There it is right there. 10 network. It was the summary route. There it is right there. Let me respond. Y'all give me a second here. I got some work stuff in here. Y'all know I've been busy. That's why I haven't been labbing every day, because even outside of work, I'm getting pinged over stuff. So he does have that summary route to take us any 10 network, take the next hop of 80.10.10. Shouldn't that be .2? No, it's .1. It's .1. So that's the next hop right there, .1. So that's correct. This floating static route should be in there. Let's see. Show IP route. I believe it is saying the 10 network to get to any 10 network. There it is right over here. That is my summary route to take me to any other 10 network, right? What is that? This is a 10 network and this is a 10 network. To make it to any of those other routes, go over here. That's the next hop. Now, the issue was, let's do a trace. Well, the trace route died right there. Let's do this. Let's put it in simulation mode and just watch real quick. Let me delete this. Bloop. And then we're going to have this PC ping that PC. I'm going to fast forward and watch what happens, right? He comes here. He stops here. Boop. And that's where I thought it died, but he made it. He was able to ping that, but he comes back this way. That was the problem. You see that? He comes back this way. We need to make it go that way. So, nope. Yeah, I'm over here like trying to do this shit and work at the same time with y'all. So yeah, that's the problem. He's coming back this way. We need to say to make it to the 10 network to take this next hop right here. That one right there. That's the problem. You see that? So coming back, he's doing what we did from the very first stream, maybe about 8 streams back. He's going that way. So we need to fix that over here. Which one was that? He is taking to get to the 10.20.10 network. Where is it? Right over here. Enable, show IP route. Show run. Y'all see where I'm getting at right here, right? Section, routes. And it's like, you would think, man, all right, all this BGP stuff we did over here, why couldn't BGP just advertise the routes that we needed? Well, the problem I think lies at was these core switches is pretty much the gateway for the local area networks back there. They're not advertising the local area networks. So that's why we have to continue doing static routes to those guys, right? That's why I think the problem is we need to continue just with the static routes, which he even said in the lab right over here, some may still need to be used. I wish you'd have put that in caps, and I was just like, well, then let me stop being so focused on BGP. So, Firestorm in the building. He said, let me see, hold on a second. Let me give you a little, get rid of this clock right over here. What's up, player? What's going on, man? He said, I remember watching you when I was working on getting CCP. Your videos helped a lot, my G. Man, I appreciate that, man. Shout out to you, man. Yeah, that's what got me to actually start this channel, was I read somewhere that said, if you're able to explain a specific topic or whatever, then you kind of learn it or understand it at a higher level. And And that's what got me to start this channel too. Plus, it was just a concept that I thought about, and I was like, yo, that would be dope if somebody explained it this way. And I did that, and they got a lot of views. I'm like, oh shit. So I just kept going, and then here I am today, right? Now I'm live streaming with y'all trying to figure out a packet tracer lab. So yeah, but shout out to you, man. Appreciate the love, man. So router 6 needs a way to get to these networks back here. He said to make it there, which was what? 10.20.10.0 and 10.20, the 10.20 networks, right? He was saying to make it there, take that as the next hop for one of them. That's good. But the other one said to take 192.168.1.9, which is where? Go this way. No, don't do that. Don't do that. Why? Because this network is down. So if you come back going this way, you're not going to make it back, right? You're going to go into a black hole there. So let's get rid of that network and say this is your next hop. Let's fix that, right? And I think that's what I had to do to fix the Orlando to Tampa network, right? So we'll copy that. But yeah, the CCNP stuff, man. You were day one. If you watched back then, I did those videos about 3 or 4 years ago, I think. Now that I think about it, 2019 maybe? Yeah, something like that, man. 2018, I don't remember. Configure terminal. So we're gonna get rid of that route. And then we're going to say, to make it to the 10.20.10 network, take the next hop of where this one was going. 80.10.10.2. Where's that? The next hop would be this right here. Pretty much the backup link, right? Because he didn't say nothing about keeping those reverse routes or those pretty much asymmetric routings, what's going on there. But he wanted that to kind of like throw. It was like a little curveball, literally a curveball to do more static routing. So take that as your next hop. So now I'm saying, how do I get to the 10? We're going to verify our work, right? Verify. 10.20.10.0 network. How do I make it there? It's my next hop, 80.10.10.2. So now let's go back into real-time mode. Let's see if Orlando can ping Tampa. Notice he got the timeout. And now he also got the reply right at the 15th ping right there. So now let's try to ping that same. Well, let's just do a trace route. We'll see. Does he eventually make it? Trace complete. So that time it worked. So now, instead of going, because this is what it was doing, right? I believe it was going this way, right? It would ping one of these PCs, but it came back, it was going this way, which he would die right there because this line is down. This link is down, right? So that was the problem, right? So now when we, even though these two links are still down, now we just pretty much just engineered our traffic with a simple static route going back the same way it came in. So take this to go there. That makes sense, guys, right? So that was that problem. So now we should theoretically be able to, well, we just saw we can at least do a trace route to Tampa, but let's do a ping 10. Oops, for anybody that wants this done in completion. 10.11. Yeah, 10.10.11.10. What am I doing here? Ping, and we got a reply, right? So that's good. Now let's see if we can ping Tampa. That was, I believe, the final task, and that was the problem. And I think it's gonna die right here. And I'm gonna show y'all what happens. Which this shit is crazy. And I don't know if this is what he was expecting me to see, but I saw that and I'm like, and I pinged him earlier today. He ain't hit me back, so maybe he was busy. I don't know. But I'm like, I think I figured it out, man. He got bigger shit to worry about, man. He got like AWS, a whole bunch of stuff on the wide area network. I'm like, worry about your damn packet tracer, man. Fuck out of here. 10.30, right? I'm trying to ping Orlando to Tampa right here. 10.32.10, right? 10.30.2.10. And what happens? It dies, right? And this is what happened. I remembered it dying over here on the last stream. Let's try and do a trace route and see where it dies, right? Let's do that one more time. Trace route. Is it Traceroute or Traceroute? I believe it's Traceroute, right? 10. No, it's actually Traceroute on the PC, right? Traceroute 10.30.2.10. That's wrong. Traceroute, right?
You stupid.
Traceroute. Now I'm making them two mixed up. Traceroute is on the Cisco iOS, right? So now we do a trace route, see where it dies. 80.10.10.1, which is just like we did in the last stream. This is where I spent like a good hour trying to figure this shit out, right? So from Orlando, Firestorm 855 said, yep, 2019, that's when I was studying for it. That's what's up, man. You were day one, dude. If you was watching my channel back then, yeah, that's what's up. And you got certified in 2020. Man, I'm glad those videos helped, man. But yeah, I appreciate the love, man. That was a long time ago, man. Y'all can see like kind of like the growth of my channel and the quality is probably the same because well, I got better equipment, but still I wasn't doing live streams for one. I was doing just strictly tutorials and stuff like that. So, but yeah, I appreciate it. I'm glad those videos help, and congrats on getting your CCNP, man. I have yet to get it, to be honest with you, because at the time I was getting the switch. I passed the switch exam, passed the route exam, but it was too late for me to take T-shoot, and I've been on this lifelong journey to pass one more exam, which is the elective exam. So I'm gonna do advanced routing and switching, which is an RC exam. So I'll get that soon. I just like, y'all know, I like labbing every day and stuff. So now we saw it went from here and it died at 80.10.10.1, right? Now, and I kept doing that, right? What is the saying that people say? Insanity is doing something over and over again, right? Or something like that. I don't remember the exact saying. Somebody wants to put it in the chat over there. But I just kept doing that last stream, right? It was like, why does it keep dying there? And I kept looking at router 6, kept looking at router 6. I was tunnel vision on router 6. I also looked at router 5 and said, maybe there's a problem there also. Maybe I got to do some redistribution. Well, you can't redistribute BGP into BGP. They already know about these routes. They're directly connected. These guys have some BGP routes, but the problem lied in local area networks, right? We didn't know how to get there through BGP. Why? Because they're not being advertised anyway. So we need some static routes to get to them. Well, let's continue doing that. And that's what I ended up doing to fix that problem. But I don't think that's what helped me resolve it. I said, you know what? Instead of pinging and still trying to ping, what is this? The Daytona PC. Let's try to have Daytona ping Orlando, right? But before we do that, let's just see if we can still ping Tampa. I think we can do that, right? Yeah, we already determined that. Tampa 10.10.11.10, right? So from this guy, right? Is he alive? What's going on with him? Oh, he's doing the trace route. Ping 10.10.11.10, right? Yeah, we determined that he worked, right? I didn't mean to do that, but so yeah, we was able to determine that worked. So we knew, even with all this going on, Orlando can still reach Tampa, right? It's a short route anyway. It's only an hour away. Right? You just take I-4 and you'll make it there. Now, we couldn't make it to Daytona, was where the problem lied, right? And we just kept doing the trace route. I just kept doing it over and over and over again, right? And it just kept dying right here. Why is that? Why? Well, does he have a route going that way? He does. But what happens if I went from Daytona and tried to ping Orlando, right? So we did that. Now, I think I did this just before the stream, right? So Orlando, the Orlando PC is 10.20.10.10, right? Let's do that. 10.20.10.10. Yes, I know I need to put Traceroute over there. Excuse me. Traceroute, right? Pinged it. And then what am I getting here? It just bloop, 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 bloop. Does anybody see what's going on here right here? Don't worry. I'll wait. I'll run it again for y'all. Shout out to Dave W in the building. Appreciate you for tuning in. You must have just got off work or something, man. I usually tuned in right at the beginning, right? We're going to get right into that Boson NetSim lab. I wanted to kind of like look at this, and then I think that's what I did to kind of like look at that issue. Does anybody see what happens here? Take a look at this trace route here. He said, all right, so this is from me in Daytona, trying to ping the PC in Orlando. Any PC in Orlando, right? So we did that, right? First hop is what? Let me close this guy. And close that guy. I believe that's the laptop, right? No, this is the laptop right here. He said my first hop is 10.32.1. What's that? That's my default. Man, let me get this up. What's going on here? That's my default gateway, the SVI that lies on the core switch right over here. Right? Y'all see that? That was the first hop. Next hop is what? 10.33.2. I believe that is this PC right over here. There it is right there. It is that router. So he go from here to the core switch to the router 8, which is participating EIGRP. Next hop is 90.0.0.1, which is where 90.0.0.1. It is, where's that at? That's over here. I don't know why that's the next hop. Let me double check that. 1033.2. Oh, 1033.2 is the yeah, 1033.2 is right there. And then he said, that's weird. Next hop is 90.0.0.1, which is right over here. That's what's weird. That's the next hop. And then the next hop right after that is 10, because if anybody can explain that one right there. But I would have thought the next hop would have been 90.111. That's what I thought the next hop would have been. But no, and apparently that's the next hop right over there. Right? Then the next hop after that is what? 110.10.1. Where's that at? That's 110.10.1. That's the next hop after that, right? Then after that, the next hop is, does anybody see it yet? Next hop after that is 172.16.1.5. Where's that at? 116.1.5. This is 1.4 network, so 1.5 is here, 1.6 is here. So he said 1.5 is the next hop. That's the next hop. Well, as you can see, there's a dead end right here, right? He says, okay, well, this guy says, all right, well, to make it to the 10.20.10.0 network, he probably has a static route, right? Let's see. What does he say? Before I even show y'all what happens, what does he say to make it to show IP route 10.20.10.0 network? He says to make it there, the next hop, take the next hop of 172.16.1.1. Well, that is what? That's that next hop right over there. Well, guess what? It's kind of a black hole and it's dead too. This line, this link is dead. So guess what the next hop for this guy is? Where's he at? After 1.5, the next hop is what? 110.10.1. That's where, that's back here. So he comes back. So he goes from, y'all see it, right? I'll run it back. With that rewinds. I need to put that in there too, I guess. He go from the laptop, default gateway, router 8, router 7, router 5, router 4. He said to make it back there, I got to take that next hop, which is right next to me, but no, that link is down. He go back this way, and then the next hop is what? 172.16.1.5, which is where? Right over here. And then what after that he says to go to 110.10.1. Where's that at? That's right over here, right? And then keep going like this. Guess what? That's a routing loop. And when I saw that, and I was like, oh shit, that's probably what the problem is, man. I don't think I got that either, man. No.
Oh shit! You're loopy.
That was pretty fitting.
Oh shit! You're loopy.
Yeah, so it gets loopy right over here. And then it just doesn't know what to figure out. So that's where we say, all right, if he says to make it to the 10.20.10.0 network, to take this as the next hop, we probably got to remove that. Let's just go ahead and remove that. That was my first inkling. But I was like, let's keep that in there. But let's just tell him, let's see what he says to make it there is. Go over here and say show IP route 10.20.10.0 network. And I should have I wish he'd have put this in all caps right here. You see this right? Some may still need to be used, the static routes, right? It's stuck in a dead end loop. Yup, exactly, Dave. It just keeps looping. And it's crazy to see that shit too, right? So even on enterprise networks, when you notice that Traceroute does that, and then you see a routing loop, and it's just up to you as an engineer to figure out. And but I wouldn't have seen that if I just kept trace routing this way, right? And that's what I did last stream. Remember, if y'all was watching the last stream, I kept trace routing this way, but I didn't do it the other way around. So I went to Daytona and tried to do it, and that's when I was able to discover the routing loop, right? So let's have router 5 and say, what is his way to get to that network, 10.20.10.0 network? He said his next hop was what? 172.16.1.5, which is what? That takes you to the dead end. So let's get rid of that route. Show run section routes, which was 10.20.10.0 network. We'll also need the 10.20.10.11.0. So we need to fix that one and this one, which is pretty much Orlando. I believe, let's see if he can still ping. Let's see if he can ping Tampa real quick. Let's see. Before we fix that problem. 10.10.11.10, right? So ping 10.10.11.10. He can ping Tampa. See that? So Daytona can make it to Tampa, but Daytona can't make it Orlando. Y'all see that? See that? Y'all hit me that like button. So anyways, now let's go ahead and fix that problem. Get rid of those 2 static routes, which is this one. And then just change the next hop to, instead of 1.5, let's make it 1. What's that? 9, 10. 1.10. We need to fix those to be 1.10. So go to global config mode, and we're going to negate that command with this, and then put it back in, get rid of the no, and say the next hop is actually going to be 1.10, and get rid of the other one, which is what? 1020 10.0 and 1020 11.0. So 11.0, which is 1020 11.0, which is this one, and change the next hop to .10. So we're gonna say, we're gonna know it out, as my coworker would say. Yeah, you got to know it out. The fuck. Get rid of that and put it back in and say the next hop to make it there is actually 1.10. And I would have thought, I was thinking, well, as I was doing this, I was like, how come BGP didn't solve that problem? Is BGP is if it's the main routing protocol that's on the internet, right? The main routing protocol, and it's, you know, it's such a godsend to the internet. Why didn't BGP didn't solve this problem? Well, I think it was because these are local area networks that are not being advertised. We had static routes back there. If these core switches were participating in BGP and advertising its local area networks, which is not really recommended anyway because they're local area networks, then I think it would have solved the problem. But we have default routes out of those networks. Remember we did it in the last stream with disk task right over here. On both Orlando and Core, replace the static route with a default route. Now, if we'd have had those switches participating in BGP, then I think it would have solved that problem. But that was the problem. That was the issue why I couldn't get to those networks. So we got rid of it, made 1.10. The next hop can, I should have seen if router 5 can ping it, but let's just see. Can I ping Orlando now from the router? 10.20.10.10. Yes, I can. Can I ping another PC, which is in Orlando, ping 10.20.11.10, and I got a reply. So now that we've done all of that, let's see if Orlando can finally ping Daytona, and then we'll move on to the next lab. Where's he at? Or we might wait till tomorrow to do that stream, but I didn't want to just show y'all the solution and then just call it a night, right? Maybe we should, though. And get some sleep for work tomorrow. We'll finally get on our knees, pray to the network guys, see if we can ping Daytona. Well, let's, for sake of good measure, just to make ourselves feel better, let's ping Tampa first, right? Which is quad 10. Get on our knees, pray to the network gods. Now he act like he don't want to ping Tampa. What's going on here? You started making me nervous there. Now let's see if we can ping Daytona. So we was able to ping Tampa. Now let's see if we can ping Daytona back here, which is 1032.10. Yeah, it should be in the cache somewhere still. Get on our knees, pray to the network, guys. That's a trace route. It looked like he made it there. So there it is right there. Now that's the trace route. Let's see if we can ping it though. Let me stop being lazy. Ping 1032.10. And we got a reply. So that was the problem. We just needed to pretty much engineer our traffic with some more static routes and then resolve the issue. I would have seen that issue. I would have seen that issue if I would have pinged from Daytona to Orlando, and then I would have seen that routing loop. Once I saw that routing loop, I was like, oh, okay, he's not going to make it because these two links are down. So I'm going to go ahead and save this, email this to my boss, and hopefully that was the solution. But as you can see, it worked. Let's move on to the next lab. If y'all want, y'all hit me that like button, hit me that subscribe button. If you want to call it a night, that's cool too.
Bye. Have a great time.
But I'm gonna keep labbing here. That's what we do here on this channel here. I'll give it a couple more minutes to give you guys a break. And where's the other one at? Boson NetSim. But yeah, man, it's crazy. I was thinking, I was like, damn, there's a routing loop over here. well, let me just fix these static routes and see. It fixes the problem. Like I said, but I would have thought BGP would have discovered that and maybe engineered the traffic or just automated some way to make it find its way over there. But because those static routes are back there, and nice. Okay, yeah, appreciate that, man. Yeah, we was able to solve it, but it was just some simple static routes that resolved that issue. But it was crazy to see that static route in action. I should have left it there for y'all and done it in simulation mode, and you'll see the actual packet going back and forth between the two routers like this here. But you kind of seen that in the trace route. That's what you're gonna see in the real world is when you start seeing, the router is coming back in the trace route, like the same IP address is coming back and it keeps coming back. That's how you can kind of see a loop that way in the real world. You're not going to see an envelope, animated envelope going back and forth to see that routing loop, but it's just crazy to see that. Next lab is static routes again. So I said with the in remembrance of these static routes here, I said let's go back to basics with the static routes here. So if you have a copy of Boson NetSim, go ahead and launch that up, and this is gonna be a CCNA level lab, so this is a little bit easier than the other stuff we've been doing. And this is the route we're gonna be working with. I mean the network we're gonna be working with right here. This is network topology. Let me go ahead and copy this. This is my first time doing this, so y'all can do it along with me. And hopefully, if you have a copy of this application, you can do it along with me. If not, make sure you subscribe to this channel and make sure you hit that like button. And then I'll be doing another giveaway soon on this channel. Now, I know I said that a while back, and I did do that, right? Now, I stayed to my promises. Gave away a copy of this application, and the motherfucker didn't hit me back. I was like, hey, you won. Left a comment, said, here's my contact information, and then... So, Prentice Adair, if you're out there, I'm still giving you another chance to get a copy of this application, right? I will be doing another giveaway soon. I wanted to wait till another subscription milestone. I don't know, 10,000 subscribers or something like that to do another giveaway. But if the first motherfucker didn't respond, then I'm just gonna give another copy away and tell him better luck next time. But this is what happens if you're not watching the network on a consistent basis, right? So this is the network we're gonna be working with. The first task here says here. Learn to add static routes. We got some basic commands that we already know about, right? Configuring IP addresses, host names, show commands, looking at the router table, etc., etc., etc. So if you're kind of new to this stuff, then this is a lot of the basics that you'll learn right here, right? This task involves configuring the 3 routers so that adjacent devices located in the same subnets can communicate with each other. So it looks like we're going to be focusing on routers 1, 2, and 4, which are located right over. Let me put my favorite application. Microsoft Paint. Been using this shit since goddamn 7th grade, right? Let me make that a little bit bigger for y'all. 125. We'll go there. And we'll move it over some. So y'all can see, right? It looks like router 1, 2, and 5, he said. 1, 2, and 4 rather. Which is located over. Bing. 1, 2, and 4. So we're gonna be focused on these guys right over here. Right, those are the guys we're gonna be working with. Now he said configure router 1 with the appropriate host name, IP addresses, subnet masks, blah 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 blah. Router 1, right? So router 1 is over this guy over here, right? The one on the top left, no, in the middle. So we're gonna configure this guy, his IP addresses, host name, etc. Right? There he is. He's located right there. We'll go to global config mode. We're in CP mode. What the hell am I doing here?
Are you fucking stupid?
We'll go to host name. That's how you configure a host name for anybody that's new, right? And router 1 is the host name and the appropriate IP addressing. So interface FA00 is 10.111. So interface, what he said, FA00 interface. The IP address for that is 10.1.1.1. Subnet mask /24, which is 255.255.255.0. And then we're gonna no shut that bad boy. Well, before we do that, he wants a clock rate of. Did I do that right? Clock rate, right? Rate, or is it just clock? What the hell's going on here? Oh, you do the clocking on the serial interface. What the hell am I doing? Subnet mask. All right, so yeah, that's it. No shut that bad boy. So that's good.
You stupid.
Get it out of this. If anybody got any questions, man, ask away, man. I don't care how simple it is. We got a lot of smart people in the chat room over there, and they can answer your question if I'm not paying attention to the chat over there. We got Kobe and Ely in the building. He said, "Give it to me." What? You wanted the air horn to shout out, man? Whatever, man. Just let me know. I hope you saw that last couple minutes. So if you're just tuning in, there was a routing loop in that lab, and the way I was able to figure that out, if you're just tuning in, is to go to Daytona to Orlando, and I was able to see there was a routing loop that happened when those two interfaces were down. So once we did that, once we just kind of engineered our traffic with some other static routes to make it to Orlando, we was able to make it to Orlando eventually, right? His IP address is 12.5.10.1. This is a pretty odd public IP address, I guess. They want to throw in there for us 10.1/24 subnet. .0. We'll give him the clock rate command of, he says 64 kilobits per second, which in this case is 64,000, like that. And we're doing no shut to bring that up. A clock rate must be configured on router 1 because it's the DCE end of the link to router 4, right? And what they're explaining here basically is, notice that this is a lightning bolt right here, which indicates it's a serial line, right? One side is going to be considered the DCE side. That's the side that's doing the clocking, right? DCE stands for data communications equipment, I believe it is. Now correct me if I'm wrong. Fact check me over there. And then the other side is the DTE, which is data terminating equipment, right? Typically, the side that is doing the clocking is the ISP, or the wide area network, the ISP. So basically, your internet service provider will be doing the clocking, right? And this is how I remember it. There's a C in the middle. That's how I know who was doing the clocking. That's how I remember it, right? When I was taking the CCNE or CCNA back in the days and stuff, right? Because of the C there, that's who is doing the clocking. So the one who's doing the clocking, the other one would be receiving the receiving end, and he will be is usually the how do they call it? CPE, customer premises equipment. So this is basically the customer side, and then this is the ISP side, right? So we got CPE versus the ISP, whatever you want to call it. So one side is DCE, one DTE, and that's what they explained in there. Configure router 2, which is this guy over here. Configure router 2 with the appropriate hostname, IP, subnet mask, refer to IP address to the table. So basically the same thing. Roster rinse repeat. So this is your first time. Now you know how to do all this shit, right? Router 2 is over here. I was almost clicking in the wrong one.
Stupid.
No, I just clicked in the wrong one. My bad. We'll go to global config mode. Give him the hostname of router. Oops. Hostname of router 2. Right, and then what the hell am I doing here? You can't put a space in host names there. Interface. What is it? FA00. And those. We're just going back to the basic here, right? Being that we got stuck in that damn static router lab, but .252.0, it's, ain't no shame in my game. You got to go back to the basics. You got to do that. Don't forget to like this video. Shout out to Ryan for that, man. Yeah, y'all make sure y'all hit that like button. With no shut NAT interface, what else we need? We enable the interface on configure router 4, so we got to do the same thing. Watch, rinse, repeat. We got to do the same thing on router 4. So what we did over here, yeah, so we configured that router. We configured that router. Now we got to configure this router over here, router 4, which is down over here. Watch, rinse, repeat, right? Go to config mode. We say host name, his name is router 4. We'll go to the interface. What is it? The serial interface. So now we're doing the other side, which is what I was explaining about DCE and DTE. So this guy was doing the clocking. He's going to be the receiving end of it, or the customer, or customer CPE, whatever you want to call it. I don't know. I don't even know what the fuck that is. I guess that's an R, or the receiving end. And we'll go to router 4. And this interface is serial 00. And his IP address is, what is it? He said it's 12.5. 10.2, 12.5.10.2. You got to put a subnet mask there.
You stupid.
It's /24.0. Shut that bad boy. And he's also clocking at a rate. No, he's not clocking. My bad. He's not doing any clocking. So remember, the other side is doing the clocking, which is what I just explained to y'all. What the hell's wrong with me?
You stupid.
Now he said on router 1, we only got 2 tasks, and we gonna call it a night, y'all. But there's like 7 subtasks between all of them, man. All right, that's not what I meant.
Oh God!
Router 1. Verify that you can ping the directly connected neighbors 10.1.1.2 and 12 tops. So router 1, we need to make sure we can ping this guy and this guy. And most likely he should be able to, because he's directly connected. Like we didn't do nothing too complex here, right? 10.1.1.2. Yes, he can. Can he ping 12.5 10.2? We got a reply. So that's yes, he can. That's a good thing. Good sign. On router 4, this is router 4 over here. Attempt to ping the FA00 interface on router 2. So now, this guy is going to try to ping. Let me do that. This guy is going to try to ping that interface right over here, which lies on router 2, right? That interface is 10.1.1.2, right? It's most likely going to fail, right? Why? Because this is a static routing lab, and that's how they probably designed it, right? 10.1.1. Oops, almost typo right there. Fat Finger Squad 1.2, and as you can see, it failed, just like I can predicted, right? The ping should not be successful. Well, I guess I didn't predict it. He said it right after that.
You stupid.
On router 2, attempt to ping the serial 00 interface on router 4. Didn't I just do that? No. On router 2, attempt to ping the serial 0 interface on router 4. So on router 2. Okay, so now we're doing the other way around. So now this guy, this router is going to try to ping that interface right over here. Right? So he's going to try to ping that. And obviously, he's most likely not going to be able to make it there. Why? Because we don't have no route to make it over there. We'll even see before you even try to ping it. Let's look at the routing table, right? We look at the routing table. He probably only got directly connected routes, right? Yes, he do. The connected route, which is this network right over here. And then the L, which stands for local, it's the local interface. It's the actual interface that we configured. That's how I remember it, right? So it's this one, the C and the L. I used to wonder, how come he got some routes in the routing table if he ain't even really we didn't really configure some routes? Well, he does. He has a network he has a physical cable that's directly connected to this network. It even says it right there, directly connected. It's directly connected to the 10.10.1.1.0 or 10.1.1.0 network. That network right there. And then we have an interface also in that network. That L stands for there's an interface that is there. 10.1.1.2. Directly connected, FA00. That's the interface that we configured. That right there. That's what that says. But they also said to go ahead and ping that router 4 interface, which is 12.5 10.2. So 12.5. What he said? 10.2. And it did not work, right? Why do the pings from router 4 to router 2 and from router 2 to router 4 fail? Obviously, we just said they're remote networks. They're not directly connected to each other. So he should be able to, for anybody that's new here, right? So he should be able to ping that guy. But he can't ping this guy because he's not directly connected until we make a route. And that's what we're going to do with the static route. Same thing with this guy. He can ping that guy, but he can't ping this guy over there. Why? Because that's another network that he sits in, and we have to create a route to do that, right? So task 2, configure and verify static routes. This task involves establishing static routes on each router to any location that is not directly connected. Like I just explained to you, router 1 is directly connected to both router 2 and router 4, so it will not need any static routes, which we just saw. You will verify the configuration with ping and show commands. After these six steps will be done, right? Router 2, configure static route. We'll go to router 2, he's over here, to the 12.5 10.0 network. You should use the IP address of router 1's FA00 as a gateway, because any traffic destined to the 12.10.0 network, subnet, can get there through router 1. So the IP address on router 1's FA00 interface, which is, he's saying from this guy, the gateway should be this. I know he said gateway, but really should be, they should have explained that as the next hop. I don't like the way he explained that. For anybody that's, if anybody that's on the Boson marketing team and you're watching this stream, believe it or not, I do fuck with them. They gave me a free copy of this application, and that's how come I was able to do that giveaway too. So, but yeah, that should be the next hop. They should have called it the next hop, not necessarily to give the gateway. But we're gonna do that, and we'll go with that anyway, with that verbiage, right? IP route to make it to that next hop. I mean that route, that network. He said we need a network to the 12.5.10.0 network. So IP route 12.5, oops, 5.10.0 network, subnet mask of /25, right? We've been doing this for the past like 2 weeks, 3 weeks, right? We should be able to do static routes in our sleep, right? So now he's saying take the next hop of, so he's saying to make it to this network, take this as the next hop. What's that IP address? It was on router 1's FA00 interface, which is I forgot. I should go on there and check, but it's 10.111, right? So 10.1.1.1. That is the next hop to make it there, right? So again, to make it to this network over here, he needs to take that next hop. So he's gonna go, that is his next hop, and that's he's gonna make it to router 1 to make it to this network, right? But the thing is, with static routes, we need to do the same thing going back the other way, right? I used to wonder, like back in the day, I explained this on my channel about 3 years ago. I was like, I remember first doing this, man. I used to wonder, okay, well, I created a static route to make it there. How come it still don't work? Well, you got to have a route coming back too. So we also got to have a route going this way. So now when router 4, which they'll probably have us do, to make it to this network, now this is from router 4's vantage point, to make it to that network, he got to go to this next hop, which is router 1's 000 interface, right? So the next step says, static routes are configured using the destination network address, destination subnet mask, and the IP address of the closest port to the forwarding router, which we just configured. On router 2, attempt to ping router 1's FA00 interface. So we're going to router 2. And we're going to attempt to ping the 10.111, which we know it should work because it's directly connected, right? So router 2. We're going to try to ping that route right there. I mean, that interface right there. So ping 10.1.1.1. I thought we did that earlier, but yes, it did work. And then he says, attempt to ping router 1's FA00 interface, router 1's serial 00 interface. So now we're going to try to ping from this router. This right here worked. That FA00 interface, that worked. Now we're going to try to ping this interface over here from router 2. So we was able to make that work. Now we're going to try to ping that right there, which is what? The 000 interface is, I can't even remember. 000 on router 1 is 12.5.10.1. So now we'll try to ping, pig 12.5.10.1, and we got a reply. That's a good sign. And then he said, why is the ping to route? Oh, and then he says to try to ping the router, the remote network, which is pretty much this one right here, which I'm gonna tell y'all right now is gonna fail, right? And then he's asking, why does it fail? Well, just to explain it, y'all, like we said, we have to have static routes to make it back. So we have a route to make it there, but this guy don't have a route to make it back. So that's the reason why it will fail. And I'll even show y'all, right? So ping the other interface, which is I forgot already. Router 4.
You stupid.
12.5.10.2. So 12.5.10.2. And as you can see, the pings are failing. So it does fail. Why? He's just explaining. He tries to explain it. Why is the ping to router 4's 000 interface unsuccessful? And just like I said, it's because coming right back, you have to have a route going there, but you also have a route coming back, and that's the problem with static routes. It takes a lot of administrative labor to do that. Imagine you have a router, a network with 100 routers, and you have to manually configure interfaces routes to every network. It's just too much administrative labor on the network engineer, and then it leaves more. It's more prone to human error because it takes the human to actually engineer these routes, right? Yes, it makes you a better, like, I guess, a better engineer to know how to manipulate routes, by hand. But it's better to just let the fucking router do it itself, right? So, and that's where these routing protocols come in: EIGRP, OSPF, BGP, and all those other routes, right? All those other routing protocols, they do that for you. Shout out to Aisha Anderson. Said, what program is this? This is Boson NetSim. It is a net simulator. It is not an emulator, so it's not real iOS, but it does enough, for you to pass the CCNA exam. David Bombo's also got. I got a question about that. Enough to pass the CCNP Encore exam and the NRC exam. So again, it's a simulator, so it simulates the iOS enough for you to pass those exams, and they ask you like a bunch of questions to make sure you understand it. That way, you're just not being a technician, just typing commands and don't know what the hell they doing, what they are for, and the purpose behind them. So they actually quiz you, and if you don't know what you're doing, you could always lab Control G or grade lab, and it shows you what you're missing and stuff like that. That's what I love about Boson NetSim. So it's called Boson, Boson NetSim. They also have exam simulators, which I heard are even harder than the real CCNA and CCNP exams. They ask even harder questions. So, and I think they give you a pass guarantee. Like if you fail it, they'll give you your money back or something like that. I can't remember what their guarantee is, but a lot of people in the networking community say that their exams are harder than the actual CCNA and CCNP exams. If you can pass those, then you'll be able to pass those other ones in your sleep. So again, it's Boson NetSim. So shout out to them, and shout out to you for asking that question. Ryan Surratt, oh yeah, appreciate that. So the next question was on router 4. So we're gonna go to router 4, which is that guy right over there. Configure static. So now that we created a static route going this way, now like we said, we got to create a static route going the other way, and then we'll be able to get, not only we'll be able to send. So the first time when we created that static route, it allowed us to send an ICMP request, but we'll never get that reply back because this guy don't know how to get there.
Are you fucking stupid?
No, it's just a router. You have to actually go in there and configure it. So remember, computers are as dumb. They're very smart, but they're also dumb, right? At the same time, it takes a human to do it, or program it rather. Go to router 4, and he said, configure a static route to the 10.10.1.0 network. You should use the IP address of router 1.0.0.0 interface as the next hop. So basically, but he says as the gateway. I don't like that verbiage right there. And I'll explain to y'all. So from router 4, he said to make it to this network back here, use this as your next hop. And that's what we're going to do with that IP route command, which we've been doing pretty much all week, right? I'll just kind of animate it for y'all, right? So to make it to that network, he got to go to this next hop, and that's how he make it to router 1. And this guy already know about this network, and he know how to forward the traffic that way, and that's how we'll be able to get the reply back, right? Because we already sent a static route to make it there. We just don't have a static route to make it back, and that's the problem with static routes, right? Not problem, but just kind of like, I guess, drawback. So on router 4, we say IP route. That is the command to configure a static route to make it to the what network? What we said network it was? The 10.1.1.0 network. So to make it to the 10.1.1.0 network, subnet mask of /24.0, take next hop of what? This right over here, which is router 1.0.0.0 interface, and that is, I can't even remember. Router 4, 12.5.10.2. That's the next hop. So 12.5. Right? It's router 4, right? No, not router 4, not 10.2. My bad. I take that back. It's router 1.0.0 interface, 12.5.10.1. So 12.5.10.1. All right, that's the next hop. We'll take a look at our routing table, show IP routes, and the static route is indicated by the, not even there. Interesting. Is it because, because he already know how to make it to that. What I meant to say was, why is he, I did put it in there. What am I doing wrong here? I would have thought he would. I would have thought he would have showed up in there. You should see a static route there. But oh, there it is right there. That was weird. Maybe I did it too quick. So I was looking for this right here. Y'all see, when I ran that show IP route to look at the routing table, I only saw the connected and the local network, right? Waited a couple minutes again.
2 hours later.
And then the static route showed up right there. And it's indicated by this S right here. We look at the legend and it tells us right there, static, S stands for static. We also have the network. This 1 indicates the administrative distance to make it there, right? Static routes, the administrative distance is 1. And then the 0 is the metric. Via what? The next hop. That's what that says. The next hop is 12.5.10.1, which is that right there. Next step was, we're almost done here, y'all. We're almost done here, y'all. Thanks. Yep, appreciate that. The next hop, the next question was, on router 4, attempt to ping, what he said? Attempt to ping router 1's FA00 interface. Why would he do that? But yeah, I guess I'm trying to see why they're trying to get y'all to do that. Attempt to ping router 1's FA00 interface. Router 1's 000 interface. What? That's kind of backwards. Okay. All ping successful, yes. So basically, we're going to do the same thing, but going back the other way, right? So from router 1, I'll show y'all real quick. From router 4. Right? He said from router 4. He said, try to ping this right over here. And then try to ping this right over here. And then try to ping this right over here. So now he looked like the damn, he looked like the, y'all remember that show, all that? This is all that. I'm showing my age there, I guess. All right, so we're going to try to ping those 3 interfaces right there, right? So we go to router 4 and ping, what was it? 12.5.10.1, which is directly connected, so that should work. That worked. And then the next interface, which is that FA00 interface, where's that at? 10.111, right? Yep, so 10 ping 10.1.1.1. We got a reply. And then we got to ping that remote network, which is from that last one right over here, right? FA00, router 2's FA00 interface, which is, I'm tired of looking over there, all that screen over there. So IP interface brief. We're almost done here, y'all. 10.1.1.2. So now router 4 need to ping 10.1.1.2, ping 10.1.1.2. We got a reply, so that's a good sign. And I think we're pretty much done here, right? So after that, he says, on router 4, view the routing table and verify that a route exists to the 10.1.1.0 network. And router 2, view the routing table and verify that a route exists on the 12.10 network. So we'll go to router 4. That's the last thing to do here, right? How do I get it to 10.1.1.0 network? We do show IP route 10.1.1.0. And I'm glad I've been doing more static routing stuff, because now I know how to filter down to just static routes by putting show. I knew that, but I never really used it very often. And now that I started doing more static routes, which my boss started having me doing, I filter down more static routes like this. And then we'll see, to make it to the 10.1.1.0 network, take next hop of this right here, which is directly connected to us anyway. And then the next one was 12. Oh, on router 2, pretty much the other way around. Show IP routes to the 12.5.10.0 network. So 12.5.10.0 network, right? So he's saying to make it to the, get rid of this all that face, that network over there, take the next hop of this. That's what that's saying, right? See that 12.10.0 network? Take the next hop of 10.1.1.1, which is this interface right over here, right? Let me triple check that. The FA00 on router 1, right? Go to router 1. Show IP, snow IP interface brief. And it should be 10.1.1.1, right? Show IP interface brief, and that is next hop, right? So we are good to go, man.
Woo! Yeah, baby! That's what I've been waiting for. That's what it's all about. Woo!
Y'all make sure y'all hit that like button, hit that subscribe button. I typically stream Monday through Thursday, 8 p.m. Eastern Standard Time, but lately I've been in this kick to try to lab every day, so it'll be sometime between 10 to 6. Oh, sorry. 6 to 9 p.m. Eastern Standard Time. Just make sure you join that Discord server. The link is in the chat at the top. It's pinned to the chat over there, and I'll let y'all know what time I stream on the Discord server. We can also verify our work with Control G or just Grade Lab, and it says right over there you completed lab successfully. So we're good to go. What else I got to say? Follow me on all social media at NetworkBruh. not all social media, Instagram and Twitter. And that's pretty much it. For now, comment, like, subscribe to the network.